Good evening. Welcome, Dr. Ahmed, or Makbul as I call you. Today is a special day. It's called World Water Day. There are a lot of events happening. Water is very, very important. Now, even water is being traded, just like oil. But DY Patil International University, Akurdi campus always has been one step ahead. So we thought, why not take a jump to moon and talk about water in the moon? So as turns out that my involvement with Moon mission was also due to water, and Makbul's involvement also has been one of the key part of his uh, contribution to Moon mission has been through water. He will talk about it, but let me introduce him formally. He's of course a dear friend and ex-colleague of mine. We are both at Institute of Plasma Research together working on nuclear fusion. And as luck would have it, he moved out and went into Moon mission. And I also had a small part to play in the Moon mission. Fortunately, I've come back again to nuclear fusion. So Dr. Ahmed pursued his PhD at Physical Research Laboratory in Ahmedabad. Those of you who are not aware, it's known as PRL. PRL is the one which started the whole space program in the country. It also started nuclear fusion in the program in the country. And both these programs grew to be much bigger than the PRL itself. So it has been, one agency, one institute, research institute, which has generated very major areas of contribution to the country. So he did his PhD in 1990 in the field of laboratory astrophysics relevant to planetary atmospheres. He joined as academic faculty at Institute for Plasma Research, IPR, Gandhi in 1992. I joined IPR in 1995, and he continued to work as associate professor till 2005. His field of interest in IPR was spectroscopic diagnostics in tokamaks. Tokamaks is something that I've worked for the last 30 years or so. Dr. Ahmed had 2 years stint at NASA Jet Propulsion Lab, USA. Jet Propulsion Lab was a very famous NASA lab where a lot of space mission related work is done. I had the fortune of going there once when I was working on Chandrayaan 2 mission. Was a research associate there during 94 to 96. And later on also one more year he went there from 2001 to 2002. Sabbatical he took at Swiss Federal Institute, EPFL, Switzerland. He joined ISRO's most ambitious Chandrayaan project that all of us are very proud of. He joined this Chandrayaan 1 project in 2005, developed a quadrupole-based mass spectrometer called CHASE, which worked successfully in the Moon Impact Probe mission. He's going to talk about it. Dr. Ahmed has been with the University of Hyderabad from 2009 as head of Central Instrumentation Laboratory. I remember that when the results that his instrument obtained were presented to the world, it created a lot of controversy. I was there in one of the discussions, and there was a lot of controversy whether the results are right or wrong. There was a lot of back and forth in this. But as Makbul will share, finally it was the point that India was putting forward was vindicated and it was accepted by the globe. So without further delay, I would let Makbul start his session. We'll have his presentation and then we can take the questions. Makbul, you're able to hear us? Can audience hear me?
I can't hear.
You can't hear?
Am I audible?
Yeah, you are audible.
Am I audible? Okay, fine. Sure. Yeah, okay, fine. I'll go ahead and thank you, Professor Prabhat Ranjan, for giving me this opportunity. My association with Professor Prabhat Ranjan goes much beyond 2.5 decades, and we have always been in contact. And Professor Prabhat Ranjan had been following what I was doing, and we discussed about the moon, my association with the moon mission and other work and all. And it just so happened he was saying that let's wait for an occasion, then I would ask you to give a presentation. And typical of Professor Prabhat Ranjan, what a day he chose. He chose the water World Water Day, to discuss about the water issues on the moon. And real truly it is his genius, I must say. He comes up with these kind of ideas, and I'm so thankful to him. And Before I start this presentation, let me build a platform. I always love to make a platform, and then I like to speak over that platform which I built. uh, Normally, water is very precious, in the sense that I remember having read and listened to many astronauts who actually go into the space and look at the Earth, and they say that the best part of Earth is such a beautiful blue colored pearl. It's kind of a blue pearl, and that blue pearl, the blueness is all because of the water. And we know that we are all living, and every other living being needs water. And everything is prospering here. Apart from solar energy, that is sun, water is very essential. And water, if you look at water on Earth, I think, though actually I'm a space scientist, I have also been teaching environmental science for quite some time. So I know the problems we on Earth facing about water. Water is going to become very precious. In fact, it's already commercial. And as per the World Organization, they are saying that we would run into a lot of big cities in the world would run into problems because of the availability of water. So how precious it is, we would learn on Earth in the next couple of years. Chennai, we know that they are struggling for water. People in Maharashtra, especially Mumbai, Pune, there are not many problems about the availability of water. But if you go to any other city, they have serious problems. You go to Los Angeles in California has not received rain for the last many years. To be precise, 6 to 7 years, LA did not receive any rain. Can you believe this? And just because of their economy, they are going very strong. They are surviving. uh, Dubai, if you think of Dubai, they have a lot of problems about water. They are planning to bring iceberg from somewhere on the North Pole or Antarctic, and then that iceberg they want to actually harvest and store the water. And those are the kind of problems one is facing on Earth. And tomorrow, when you want to colonize and you want to stay on the moon, you need water. And water is very essential to be able to colonize on the moon. So with this introduction, let me start my presentation. So I roughly try to cover these 4 points, starting from the lunar water history. I just poke a couple of points here and there. This will be very haphazard. This is not well organized, and please forgive me for this. But I would only try to emphasize that water discovery on the moon has lots and lots of hiccups. And the instrument which my team built in ISRO has played a very crucial role. So eventually, at the end of the presentation, you would realize the role played by me, my team, ISRO, and India as such. That is the impression I like to leave at the end of the presentation. I would also like to tell you about the whole thing was done under the program of Chandrayaan 1. India aspiring to go to the moon. India went to the moon, and then I'll introduce you the Chandrayaan 1 mission as such. In the Chandrayaan 1, there was a special mission, which was a pet of President Kalam, called Moon Impact Probe mission. And I was part of the Moon Impact Probe mission, wherein an experiment was done. And the experiment was done called the CHASE, India's Science Experiment on the Moon. CHASE stands for Chandra's Altitudinal Composition Explorer, a mass spectrometer which was sent and was allowed to fall on the moon. And that experiment is all my experience was. So I'll try to emphasize about details about that experiment, which went there, and the sole purpose was to find various species which are around on the moon, primarily about water. So let me just take you through. As in my abstract, I mentioned that humans always aspire to go to the moon. I'm sure, as I wrote in my abstract, Galileo would have been so glad, so thrilled to look at the moon, and I'm sure he must have been upset to realize that the so-called mares, are the seas on the moon, never existed. Moon is all barren. It's all barren. There is no atmosphere. It's all sandy dunes on the moon. So apart from that, there was a cold war in 60s. Within couple of years, 2 to 3 years of Russia sending a rocket into the space, you can see that 3 years, 56, the Sputnik was sent into the space, and 3 years Russia was actually going and trying to measure magnetic field on the moon. And you can see similarly, the America followed, then Russia, America, Russia. You can see. So there was kind of a cold war between USSR and the US. And you can see that there were many firsts achieved by Russia, USSR, soft landing, going and revolving around moon, and go to the moon and come back to Earth with a sample. And then the Americans took over. They started really working hard, and then they said that we will put a first human on the moon. So in a way, moon was actually the place where you show your prowess. If you want to say that you are a very good athlete, then maybe you just prove it to the world that you can win 100 meters race. So it's some kind of a 100-meter race where any humans, that any country can say that, yes, I can run that race and show it to the world that I'm actually technically very competent enough. So that was a kind of thing which went on, and history has shown. No, I'm not trying to glorify the Cold War, the thing lied between USSR and USA, but indeed it was there. Many historians, including Americans, wrote a lot of books about this particular kind of a Cold War between USSR and US. So the Americans did a fantastic job. They landed 12 astronauts on the moon, almost starting from Apollo 11 to Apollo 17. The last man to walk on the moon was Yugen Cernan, and they brought almost 20 kilograms of samples from the moon. They drove rovers on the moon, and they did lots and lots of experiments on the moon. And they spent, I wish I could go into the greater details of Apollo saga, Apollo era, which placed America, NASA right on the firm footing, and they were proven to be the best among space explorating nations. But believe me, with all that, still there were a lot of questions unanswered. And as I mentioned, slowly in the beginning of this century, the Asians started going and trying to explore the moon. First Japan went, then China went a year before, that is in 2007. Within a year, India also went. So that's how the lunar exploration started. But neither Japan, China had made such a full impact or a greater impact, that is of finding water on the moon. And why water is so crucial? So if you just back of the envelope calculation, if you do, roughly the experts say that anything you want to take to the moon, it will be around $10,000 US dollars per kg. So, or if for that matter, if you want to take 1 liter of water, it would almost cost you 7 lakh rupees. Roughly, the price is coming down though. Thanks to Elon Musk, the price is really coming down from $10,000 per kilogram to maybe 5,000. The people are expecting it to be 2,000 per kilogram. So that's how, if you want to stay there and for a long term, which is what NASA is planning. NASA is planning to send 2 women for the first time under Artemis program and have a outpost made at the south pole of the moon. The program is called Artemis. And if they want to do so, they better have water for them so that they can stay there for very long. And the water is very essential also to understanding the early phases of lunar evolution. How exactly the moon formed. In fact, the theory, the basis about moon forming is not quite well understood, even though among the couple of competing theories, it is believed that it is the collision of one object with the earth, and then eventually that object got captured by the earth's gravity, and that's how it formed a moon. So that can also be understood if we actually find out the lunar water. And the instrument which my team built played a very crucial role, and that is all I'll try to tell. In fact, it changed the mindset of Apollo era, which the scientists till the Chandrayaan 1 thought that moon is barren. We were the first people to say that moon is no more barren. The moon mineralogy gets the credit of publishing the paper and the credit of being the discoverers of water on the moon. I'll take you to that point later. And one more experiment as part of lunar reconnaissance orbiter called L-Cross, and they too did an experiment. If I have time, I'll go into this, or otherwise there is an intense search for finding water on the moon, so that you can do lot of experiments and stay there as an outpost. So there is an important thing called in situ resource utilization, ISRO they call. So there are many ways by which you can go there, stay on the moon, and there is no atmosphere on the moon. You need oxygen also. Here is the case where the Lockheed Martin has said that if you can somehow make use of the hydrogen, which is part of your rocket, and then make use of the lunar soil, they demonstrated it on Earth. This is not on the moon. This is on Earth. You can actually produce oxygen and survive with that oxygen. And of course, you can produce some amount of water also. But this water will not be so much usable for consuming and all. It may have problems. So you need to find another solution for water. So if you can find water on the moon and you make oxygen by ISRO, that is in situ resource utilization, then you are in the business. And that's what humans are trying to do. They want to find water on the moon. Let me just jump across to one more. These don't bother about the way I'm jumping from X to Y, Y to Z, and the story will culminate very nicely once I stop at the end. So in 2010, by employing secondary ion mass spectrometry from the lunar soil, they found out that there is a huge amount of water. So they kept on trying to say that yes, there is a water. If you recall, the Chandrayaan 1 was in 2008, and this was coming in 2010, 2 years later. And then L-Cross is another experiment carried over by Lunar Reconnaissance Orbiter. They call LRO, which is the NASA's spacecraft, which is revolving around the moon even today. So they also actually slammed part of the rocket on the moon, and for the first time they said that yes, indeed there is a water on the moon. And even though it was 2010, 1 year later than the Chandrayaan 1 experiment. And in 2012, the Lunar Reconnaissance Orbiter actually carried a laser, and they actually scanned through the Shackleton crater with the help of the laser. They found that the crater could have an abundance amount of water. And there is another H-alpha experiment which looks at hydrogen Lyman alpha, not the Balmer alpha, which also gave conclusive evidence that the crater would possess a lot of water, which would have been staying there because of the impacts of the comet for not millions, billions of years. And these are the permanent shadowed dark regions where the solar light will never reach. So I'll come back to these issues later. There is one more controversy, or one nice article written by Arlen Krotz, and who says that the Indian instruments data was not allowed to be published for 10 months. He also goes on to say that Soviets did find water on the moon in 70s itself, and Americans never accepted it. So there was an intense lobbying by the Western world to suppress the lunar water discovery. Lunar water discovery carries a huge importance. Imagine the Americans who did so big. I mean, they're kind of big brothers in the world, and if they have not found the water on the moon, and it was the humble Indian probe, in fact, built by my team, if that would have got the credit, and I will prove it to you that it is I managed to convince the Western world that it is the instrument built by India which was responsible for finding water on the moon. And I think I need to go slightly quickly because I got another 20 slides, and I will just go past this slide. I will just try to impress upon you that how do we go to the moon. The PSLV will launch you in an initial orbit, and then in your spacecraft you have carried the fuel and liquid apogee motor, they call LAM, and with the LAM you just fire LAM, raise your orbit once, twice, thrice, 4 times, and then the moon is somewhere and it will be coming there. And the last time, that is from 266 kilometers from the earth, you raise your orbit to 386,000 kilometers, then you fall in the vicinity of the moon, and then you get captured by the moon. You make any mistake here, that is from earth orbit 4 to be captured by the moon, then you will never be captured by the moon. So there was a moon ranger. If you can Google and check that in the moon ranger set of experiments, America tried to reach out to the moon. Out of their 9 attempts, they failed consecutively 6 times. Only on the 7th time they got captured by the moon. So reaching the moon itself was a big deal, and India reached the moon in the very first attempt. That's a great achievement by India. Not to really praise beyond my capacity, I'm just trying to say that this is all the history which has taught us lessons. From the history lessons, we can say that we did a fantastic job of being captured by the moon in our first attempt itself. This is the spacecraft Chandrayaan-1, which is almost 1,400 kilogram at the time of launch. And then by the time it reached the moon, 650 kilograms, a lot of fuel was spent across by liquid apogee motor, and instruments were carrying only 110 kilograms, very small amount. And then the mission, the Chandrayaan-1 had only 5 instruments from India. The remaining 6 experiments, India gave a free ride to the best player in the world: X-ray spectrometer, infrared spectrometer, X-ray spectrometer from UK, the infrared from Germany, and then for atomic reflecting analyzer from Sweden, the radiation dosimeter from Bulgaria. And these are the 2 fantastic state-of-the-art instruments from NASA, the Moon Mineralogy Mapper and the Synthetic Aperture Radar from NASA. That is what the Chandrayaan-1 carried, gave a free ride to these guys. And it is such a fantastic forethinking, a very good thinking on ISRO's part, that the Moon Mineralogy Mapper, the state-of-the-art infrared spectrometer, claimed, and it found, and they could manage to publish before the Indian instrument, and got the credit that they found the water first time on the moon. And what all did we do in Chandrayaan-1? We spent 380 crores. And as per President Kalam's dreams and his desire, the tricolor was actually was sent and fallen on the south pole of the moon. And it was for the first time, never ever in the history of moon that 5-meter resolution images were taken. And first time ever it was brought out by Science Journal. You can say that there is a water on the moon. So the credit, if not goes to my instrument, it will go to Chandrayaan-1. And such a great thing happened. And nobody can take that credit away, that it is the Indian probe which carried the Moon Mineralogy Mapper, which found the water on the moon. And that was a global effort on India's part, going to the moon. We were the 4th nation after USSR, US, Japan to go and touch the moon. And then we were at par with the leaders, and this gave an opportunity for India to go to Mars. And I'll quickly go through a couple of slides of Moon Impact Probe, and then I got 4 slides of my instrument, and then the water discovery. So I got around 10 to 12 minutes, and I hope it will be fine. If I'm running out of time, if I'm told that I can wind up, I'll go slightly quickly. So I got another 10 minutes or 12 minutes or so. This is the Moon Impact Probe which has fallen on the moon. And what is Moon Impact Probe? As you revolve around the moon, the first thing was, this is Chandrayaan spacecraft, green was Moon Impact Probe. It got separated and went and fell on the south pole of the moon. It took around 22 minutes, and it took fantastic pictures of the moon. First time ever the color pictures of the moon were taken by Moon Impact Probe camera. A commercial camera carried by Moon Impact Probe. You can see it has taken when it was 25 kilometers above, and it is just before the impact, and it had an impact. And it was proved that where exactly the moon impact probe fallen. This is the Shackleton crater. I showed you one of the pictures where the lasers were employed, and here the solar light has never ever fallen in Shackleton crater. In any one of these craters in the South Pole, this is the South Pole where I'm showing the arrow. So never the solar light, the sunlight has fallen, and the moon impact probe falls just near the rim of the Shackleton crater. And this is the Malapad mountain. And let me just tell you what is the problem, or what exactly was the challenge for us to build an instrument. On the moon, we have fantastic blue color water everywhere, and we have 760 torr of huge atmosphere, 10 raised to 19 particles per cc. We have an abundance amount of oxygen to breathe in. On the moon, there is no atmosphere, absolutely none. 10 raised to 19 particles per cc, on moon 10 raised to 6. For a common man, it is an absolute vacuum. For a composition scientist like me, I still got huge amount of particles, 10 raised to 6 per cc, as against 10 raised to 19 particles. And there is none is known about what all is this 10 raised to 6 particles per cc. Roughly, they said helium, neon, and argon, a bit of hydrogen could be there. So the biggest challenge to me and my team was to build an instrument which can measure that absolute vacuum, that is parts per billion, or 10 raised to 5 particles per cc. Can you measure this? And that is what our challenge was. And my team, I'll just introduce my team. Chandra's Altitudinal Composition Explorer. Fortunately, there is an instrument called Quadrupole Mass Analyzer which can do this job. This is that Quadrupole Mass Analyzer. I call it Chase. This was built at Space Physics Laboratory, Vikram Sarabhai Space Center. And this is my team. And I want to bring attention to these set of folks. Srilata was a MTech and later on became PhD. And Pradeep is BTech in electronics engineering. Tirtho is MTech from Kolkata University. And Neha Nayak is MSc Electronics from Gujarat University. So we had women, we had people from all walks of life, all different degrees and all, myself, and we had zero experience in building a space-borne instrument for the moon. And our boss, Professor Sridharan, had some experience participating in Indo-US experiments in 70s. So with his experience, we went on this particular journey, which was very, very tough, where we qualify a commercial mass spectrometer into a space-borne instrument. And we have to characterize it, we have to ruggedize it, we have to solve data acquisition control problem, we have to cross the Lakshman Rekha of thermo vacuum test, vibration test. I wish I could speak on each of these steps for almost an half an hour, whereas I got to wind up in 10 minutes. And I felt as if this guy is clicking his selfie on Mount Everest. And I also felt as if I'm standing on Mount Everest, having crossed all these steps, and making my flight model, gave it for PSLV team that take it and send it to the moon. And characterization, I wish I could go into the details. I'm running out of time. I will very quickly say a couple of sentences on each slide by saying that you have to prove it to ISRO that in this instrument will measure the lunar ambience 10 raised to minus 10 torr. It's a big deal, actually. It's a very, very big deal. And we did that in almost 2 years of time. We have to make it very, very strong, where for Earth, we have actually experienced 1 G force, whereas on Moon, you take a ride on PSLV, 22 G force, enormous amount of vibrations. You have to survive that. And that problem was solved, mechanical engineering problem purely, and we solved it. And then there was a problem of isolating a computer. We did a fantastic reverse engineering, and we got rid of, and Neha Nayak, whom you saw here on the right hand side in my slide there, she became a hacker. She found out what all data is being shared between the computer and my instrument, and she grabbed all the data, put it on a FPGA, and that FPGA was actually replaced with a computer, and then we got rid of the computer. A classic reverse engineering case involving computer sciences. And these are the two Lakshman Rekhas I was mentioning about, the vibration test, which you are seeing here, and the thermo vacuum test. I wish I could go into the details. And if you cross this, you feel very, very relieved, and then your instrument is qualified. to be able to take a ride to the moon. And the instrument which we built, and if I compare with any of the instruments built anywhere in the world which went to the moon or to planet Saturn by NASA, our instrument is 100 times better dynamic range, 10,000 times better sensitivity, and weight wise, just like Sachin Tendulkar, it is 1/3 of the mass. But it can have a huge impact player, how Sachin Tendulkar was. Like that it was. And this is the instrument which I'm carrying, which is no more there on Earth. My baby, 15th August 2008, we gave it to the ISRO team, and it has gone and fallen on the moon. I look at the moon from my ninth floor flat, right at the south pole of the moon. This instrument has fallen. Nobody can take this feeling from me. I feel so immensely satisfied and content that the instrument which I built has fallen on the moon. Okay, let's talk. I'll just take 4 to 5 minutes from now on. So we never ever say that we found water on the moon. There is no water on the moon. And the way it was found, this is slightly abstract. Please bear with me. And then I'll come back to the next 2 3 slides, which are very easy. So the Moon Mineralogy Mapper of NASA actually is a remote sensing instrument. Their paper was accepted. The mini synthetic aperture radar is actually a remote sensing but active probing by sending microwaves, and they found positive signals. They also got their work published. Right at the last, after these two guys published, the chase work, the mass spectrometer, was a direct measurement where our instrument actually flew down the moon, sampled the local ambience, and found water on the moon. If I just show you the direct evidence of water on the moon, this is the paper we published. If anybody is there from chemistry, they would appreciate that we found a fantastic mass spectrum from 0 to 100 atomic mass unit, and we found abundance amount of water with no contamination, a clear spectrum that there is a water on the moon. No details, but please pay attention to this. This is pathetic to say that the Chandrayaan-1 was launched in October 2008. The Moon Impact Probe experiment was ours. Just in couple of months, just in next month, the Moon Impact Probe experiment was done. We found water on the 14th November. We were jumping in Bailalu in Bangalore. We sent the first draft for publication, and our paper got rejected. At this time, the Moon Mineralogy Mapper was not even switched on. And then within 8 months, the Moon Mineralogy Mapper, I'm sorry, this is October 2009, their paper got accepted. And then Chase gets 2009, this is Chase gets its paper in the next year, March 2000. This is March 2010. I did this slide, I prepared it today, so it was all in hurry. Let me go back again. 2008 October launch. Within a month, Moon Impact Probe. Within a month, first draft is sent for publication in 2008. Nothing happens, our data gets rejected. Moon Mineralogy Mapper 2009 October gets published, and then another 4 to 5 months our data gets published, 2010 March. And I struggled, and I kept on saying that it is our instrument which found water on the moon. This is the science paper which was published in 2009 October. Please pay your attention. Then after 10 years, I fought with the science team, and then I sent a e-letter, succeeded, and my letter is accepted in 2019. After 10 years, I can proudly say that the discovery of water on the moon lies with Chase, and I being the team leader, it was me whose paper, e-letter, was accepted by Science Journal, and I can say very proudly that India is the one which has found water on the moon, and it's an amazing feeling. These are the blogs I write, and I bring back this slide later. And with this, I like to stop my presentation. And thank you so much for all the listening to my talk.
Thank you, Makbul, for the fantastic journey that was, and congratulations.
I really can't hear Professor Prabhat. Maybe.
Okay, maybe you remove your thing. Others are able to hear, so you remove your earphone. Okay. Okay, I'm asking him to remove his earphone. Let's see if that works out. Okay. because we were talking before that. And can you hear me now? Audience is able to hear me. Okay.
Yeah.
Can you hear me now? Take. You still can't hear. Okay. Right. I will just. Okay. Yeah. Can you hear now? No. We were.
Yeah. I can't really.
Okay. So audience is able to hear. He is not. Okay. Can you hear me now? No.
Yeah.
You
I
can't
can't
hear.
really hear. Uh,
Everybody is
I
able to hear.
can't
You can't.
hear. Uh,
Okay.
uh,
Okay. All right. Amit ji, maybe you can highlight some of the questions that the audience asked. Or
yeah.
can you hear me now? So there is a question about. Yeah. Okay. Can you answer this? Okay. I would try to answer this question, Kumudji. Actually, it says the question is, sir, does the presence of water on the moon substantiate if there is a life or probability of life in future on the moon surface? So I don't think
Okay,
substance.
sure. I think I'll take the questions. I'll take
Yeah.
the questions as they
Okay.
appear. And sir, yeah, presence of water on the moon substantiate if there's a life. Yeah, absolutely. As per Kumud's question, the life on any object, extraterrestrial object, is really connected with water in a way. But the amount of water we are talking about, it's a minuscule amount of water. It's very less. So by no means we can say that there could be a life on the moon. However, you need many more things apart from water also. So the small amount of water which could be buried very locally in the craters, that is only in the south and north pole, doesn't really assure you by any mean that there could be a life on the moon. A different scenario would appear for planet Mars. I think we can discuss about that later, but I think let's worry about moon first. Yeah.
Yeah. Chandrayaan 3.
If
Chandrayaan
there are
3
any
question.
questions, I would be so happy to take questions. Yeah, Pranay. Yeah, Chandrayaan 3. Pranay is asking about Chandrayaan 3. Yeah, so Chandrayaan 3 actually was to take place in this year, that is, let's say 2021, but they are saying that they have so many other commitments lined up. They would take up in 2022 is what it came in the press. As such, I don't work for ISRO. Please don't treat it as official stand. I just learned it from the press. Yeah, we will be glad to answer any question. Please
Dr.
go ahead and ask.
Dr. Sasi Singh's answer question.
Yeah. Somebody's asking about the pain. Yes, I like to just explain one thing. All along my life, after I failed to publish the paper, I used to see a dream. In my dream, I see that I am taken to the Indraloka. I've seen a lot of Puranic films where I have seen there is a Lord Indra there, and then there are all gods sitting very next to Lord Indra. So Narad Muni takes me to Indraloka and says Narayana, Narayana, and he says that here is the guy who found water on the moon. And I raise my head up and look at Lord Indra, and then I get up from my dreams. And that's all I was seeing for 9 to 10 years. The day I got my paper published in Science Journal, I don't see the dream now. And I'm so thankful that that I think I got the name for India, and I got my own name written on Science Journal, that the discovery of water chronologically lies with my instrument.
Right. Any other questions?
Thank you, Saurabh. Thank you. Thank you, Gautam. Yeah. If you got any question, I'll be so happy.
Dr. Gautam Goswami is my colleague at TIFAC. We worked on Technology Vision 2035 together. I would, in the meantime, as we are waiting for questions, I would share some of my experience while we wait for a couple of more questions. I also got involved with Chandrayaan 2 mission, actually. This what Dr. Ahmed mentioned was about Chandrayaan 1 mission. Chandrayaan 2 mission, I was involved, and it was due to water only. Makbul touched upon this point a little bit, but not in detail. I was giving a talk at Space Application Center on some of my work to young trainees. And during that, this was around 2006, when I mentioned that some of area of work that I am doing actually may be useful for Chandrayaan mission, but I did not know what kind of help it would be. I did not have much idea about Chandrayaan work. Later on, as it turned out that my work had application to detecting water in what is called permanently shadowed regions of the moon. So Makbul actually showed you some pictures where there are craters like Shackleton crater and so on. These are permanently shadowed. The temperatures are minus 200 degrees centigrade. The temperature is so less because sunlight never goes inside that. It is in the polar region. So sunlight goes at tangent. And we wanted to detect water in those permanently shadowed regions. And those regions are very important because they could hold a lot of water. And actually, he mentioned about this. So finally, I was asked to develop a system which can go inside those craters with temperature minus 200 degrees centigrade and then detect using sensors whether water is present or not and send the data back to Earth either through the rover or through the orbiter. That project got funded in 2009. I started working on that, but the mission plans changed actually. And then 2010, I was asked to work on in situ. Whatever experiments had to be done on Chandrayaan 2 on the rover, I was requested by ISRO to actually develop an integrated system to do all that work, and that I called LUSEX, Lunar Surface and Subsurface Explorer. But for various reasons, that project did not get funding, and then I got busy with some other tasks, so I could not take it up. So that was my experience. Dr. Sasi Singh has another question that or comment. Maybe you can, Amit, you can put it up.
Yeah, I can hear everybody now. I had to just choose another audio system. I'm on now. Yeah.
Great. Yeah. So
Yeah.
Dr. Sasi Singh is making one more comment.
Yeah. I think Supriyo is there, my colleague at PRL Ahmedabad.
Okay, good.
Yeah, okay. So Supriyo is actually asking about the isotopic hydrogen values. Unfortunately, the quadrupole mass spectrometer we carried, it would actually give a mass resolution of whole mass, that is 1 AMU. So it won't say about the isotopes. In fact, for planet Mars, ISRO carried Lyman alpha, deuterium alpha ratios photometer that would tell about hydrogenic composition ratio, which would tell about the loss of atmosphere from on planet Mars. So there, even though it so happened that the radiometer did not work properly, but that was the best bet to do, or you need to carry a high resolution mass spectrometer, which is very, very tough. So we were more keen in finding the whole masses, and hence we carried that quadruple mass spectrometer. I'm audible now. I can hear everybody, so people can
Yeah.
ask me. Yeah.
So actually, Amit Kumar has a comment. Maybe Amit ji, you can highlight. Yeah. Sorry. Yeah.
Yeah. So regarding the moon mission, India has done a fantastic job, as I try to impress upon in this presentation, that the water on the moon lies with India. That is with Chandrayaan-1. So if you ask me, where does India stand? India stands right on top as far as the lunar exploration go. Maybe tomorrow the NASA is sending their people and they are building an outpost on the South Pole. But the fundamental work, that is discovery of water on the moon, lies right with India. Even though the chase is slightly some kind of a misfire, I would concede it. I don't really bother. The credit has not come to me, but it did come to Chandrayaan-1, the spacecraft, the efforts made by all ISRO and all. So India stands right on top on the lunar exploration. This is not exaggeration by any means.
So Makbul, and if you were to plan a moon mission for India, next future moon missions, what all you would want to do?
Yeah. Actually, I gave a lecture at the UAE University where, after going to Mars, they were actually planning to go for moon, and I did a lot of preparation about what all to be done, and this question falls right in that area. So the exploration of moon is all over now. So the question is to survive on the moon. To be able to survive on the moon, the number one point is in situ resource utilization. There are a whole lot of labs in US, MIT, and many places in US, and DLR in Germany, space program. They are pouring millions and millions of dollars and finding ways of means of harvesting the local resources so that you can survive first and then try to pull on. So the in situ resource utilization is where India should be looking for. The private universities, the IITs, they all should be looking for surviving on the moon rather than doing any exploration. That's all done now. We have dozens and dozens of exploration instruments and volumes of data published on that.
So one more question that I would want to ask you is that in the space is becoming a very hot area, and a lot of resources are there, especially like asteroid mining and so on, and other resources. Can moon act as a base for space exploration? What do you see?
Actually, this is one of the contemplation that this is the need to be done. In my view, moon as a stepping stone for, as you rightly said, going beyond the Mars orbit is quite far stretched, and it will take huge amount of efforts. And you land on the moon, make a outpost, and then take one more hitchhike ride to the asteroid or to the later planets. I think it's really, really too far stretched. More than that, if we could actually do much more attempts to reach to planet Mars directly from Earth and come back from planet Mars, then have an outpost on planet Mars, that is much more doable than using moon as a stepping stone.
So one more issue that actually it connects both of us again, nuclear fusion and moon mission, is the use of helium-3.
Yeah.
So moon can be a good resource for helium-3. Do you have any comments on that?
Yeah. It's a very good, fantastic question, actually. And nobody would have appreciated much more than Professor Prabhat, who has actually spent all his life in nuclear fusion and then moved over. And a guy like me, I spent around 14 to 15 years nuclear fusion. President Kalam's classic idea of moon impact probe is this only. even though symbolically you go and embrace the moon, but try to do cutting edge science experiment. When my mentor, Professor Sridharan, actually proposed this experiment of flying a mass spectrometer, it was back of the mind of all the scientists in ISRO and Professor Sridharan and us, is that can we actually build that instrument with such a very high sensitivity that we can pick up the helium-3? Can we do can we measure, can we look for that nuclear fusion based any fuel materials, which is highly contemplated that they could be surviving on lunar regolith and surviving on the moon, because moon doesn't have any atmosphere to offer. All the solar radiation actually can get trapped in the regolith, and you can find them, or it could just come out later slowly. So the question of finding, sending a very sensitive mass spectrometer was a challenge. I think that was all achieved. Problem with the moon impact probe Chase, the one which we built, was it was 20 minutes experiment, and we were not hoping to do much. Right now, as I speak to you, a sister of Chase or a brother of Chase is called Chase 2, revolving around moon at 100, almost 100 kilometers polar orbit. If at the time of ending of this mission, the spacecraft would slowly shrink its orbit, go closer and closer to the moon. So the best bet to look for any of those fusion ingredients could be either to have a rover roaming on the moon, or getting very close to the moon, such as lunar reconnaissance orbiter, which is at 50 kilometers. And that option is always ready, and ISRO is looking for it.
Right. Now, there are some more questions. There's another question about what is chances of life on the moon by Kusum Rajpurohit.
Yeah. So I think if you want to ask this question, please ask the guys who are working on planet Mars, and they are also scratching their head, and they are very close to find bacterial life at the subsoil level of planet Mars. Moon is a terrible place to ask this question. There is no atmosphere, and the temperature goes to almost 100 plus in the daytime and minus 120 degrees in the night time on anywhere on the moon. And on the craters, as Professor Prabhat was pointing out, it was much minus 200 and all. So don't ask for a life on moon, and for sure, take it from me, there's no life on moon. So ask for Mars.
So Makul, actually, as such, life doesn't exist, but there are plans to have human habitation on the moon by proper things so that we can exploit the resources. In fact, some of the work that I was doing was actually trying to find out the subsurface structure to see whether it is suitable for building structure. And I think you pointed out this, but maybe it got lost out, was that India was probably the first one that was trying to land on South Pole of the moon in the Chandrayaan-2 mission, which is very important for human habitat. That's the most comfortable area to live in. So we can have artificial, so we don't expect life to be there, but as a human habitat for exploitation of moon. Or I'm still expecting that moon having low gravity, it's easy to take land on the moon and take off from moon. It may serve as a refueling station or other purposes. You can build a factory there to do certain things. So there may be possibilities of lunar colonies, which are artificial colonies, prepared in a way that it could serve as a base station of some kind. That possibility is there. Amit is asking one more question about the reverse computer technology that you talked about, which you replace the computer, the FPGA computer, to pick up the signals, pick up the protocol that was going on the communication that was taking place. So understanding that communication, replacing the computer with the FPGA to make it very small. I think that's what he wants to know.
Yeah, I'll respond to your point, what you mentioned. Yeah, it is very much true that a lunar ride, just the powerful rockets of America would take you in a day, 1.5 to 2 days, 40 hours or so, and then you can come back very easily. So you can do a lot of experiments on the moon. And right now, China is already trying its ultraviolet telescope to look deep into the space at different aspects of the extraterrestrial objects. Very much right. So. And colonizing the moon is very easily possible. All that is there on the cards. It's very easy. In fact, apart from SpaceX, the Virgin Atlantic is actually having bookings for taking humans to the moon as tourists, and they want to bring them back. Many people enrolled, and they are all planning. Iranian lady, I'm not getting the name, one entrepreneur. She, apart from going to the space, she wants to go to the moon next. So all that is possible, and it's on the cards. Now coming back to the reverse engineering part of the what went on between my instrument and the computer was the following. There was a processor called Atmel processor. Atmel processor, the silly processor which was there in my instrument, was having a different family, it belonging to a different family, which was only having a small amount of data in its ROM. Most of the data to be sent out from the controlling computer. Because of that, it was becoming extremely tough for us to actually capture all the data, and then we could not see what is going on between our instrument and the computer. So believe me, in 2007, the Google, I think Mata was just available, and I Googled and I found out, and I don't have access to internet. I stayed in my small one house somewhere in Trivandrum, and then Googled and found out that there's a thing called serial sniffer software. One German young boy in 2007 built a software to give it to the company people to find out what is happening between their input hub and all the employees. So if I go to my office and read Times of India, my boss will find out that I'm reading Times of India. And that's all thanks to serial sniffer software. And that software I installed on my computer, trying to find out what is going on between my instrument and my computer, and I grabbed it. I ran into a problem where there was a handshake taking place a couple of times, and it was changing the baud rate. And it was next to impossible how to find out the change of baud rate. And my team members spent 6 months to find change of baud rate, and it's kind of a national secret. I can't disclose it on this talk. Also, I've never disclosed even to my wife, who happened to be a PhD, that how we solved that change of baud rate problem. We figured it out and found out and captured all the data, put it on FPGA, and ran our instrument.
Sure. Thank you, Makbul. I think we are coming to end of this session. I just wanted to add a couple of more points here. One is that in US in 2015, there was a company called Moon Express. That was the first private company given permission to go to moon. And that company was set up by an Indian guy called Mr. Naveen Jain. He's a serial entrepreneur. And so even in the US, the first company is to try to go to moon is called Moon Express, set up by an Indian guy. To come to the end, I would also like to say that we're fortunate to have Makbul join us at a very short notice. Today morning, when I saw World Water Day, I remembered Makbul, and he thought that why not take a jump from Earth to moon and talk about lunar water, and who else is better than him. But to audience, I would like to tell you that the university, PATIL International University, has been around for 3 years. And within a very quick time, we have become the trendsetter for the whole country. For example, computer science and engineering, we set up a curriculum in 2019. And today I'm happy to report to you that all over country, it has led to change in computer science curriculum, including by AICT and so on. Just on Friday evening, I was given an award for that. And this is all because of the things that we are doing, which is to actually take bold steps. And India took bold steps in Chandrayaan mission, and I'm sure that will continue to do that. I'm also happy to report to you that first time in the country, our university has got into nuclear fusion. So we have started with private investment from Silicon Valley in US, a nuclear fusion program in the country, which is based out of the university. The physical facility, of course, we'll have to do it outside the university because of the space and other requirements. But many people have joined. Makbul doesn't know this, but many people from IPR have joined this project right now. There are 5 of them have joined, and more are going to join. And I've called this project as Project Sanlayan. Project Sanlayan. Sanlayan in Hindi, actually nuclear fusion is called Nabkiya Sanlayan, or in Sanskrit. And so I've called this Project Sanlayan. And actually our goal is, one is of course to produce energy. Second is to produce medical isotope. And third is for space propulsion. So space propulsion technology using nuclear fusion engine. So these are the 3 immediate goals that we have. We actually want to manufacture medical isotopes in short-term goal. We're trying to look at that from 3 to 5 years. There's very severe shortage of medical isotopes across the globe. Second part is the energy part, that we expect that it will take about 15 years time, 14 to 15 years time, to commercialize. Now, Makbul would not believe this probably, because all the time we thought that nuclear fusion may happen in 2060. It was always in future, always in future. But things have changed. High temperature superconducting, high field magnets have come into play. That is changing the game completely. A project like ITER has worked on the technology of low temperature, superconducting materials and not so high magnetic field. But due to this advent of high temperature superconducting magnets, which also produce high temperature, high field magnets, suddenly the game has changed. So actually, we are able to now plan to have ITER kind of performance at 1/10 of the volume and then much lower cost, 1/30 of the cost. And of course, the size becomes small, the design becomes small, and the time to set up things also becomes small. These have become the game changer. And fortunately, our university, PATIL International University at Akurdi campus in Pune, is the first one in the country outside Institute of Plasma Research, where both of us have served, has started this kind of work. And so I'm very, very happy to report that we are right in this game and connecting a space, nuclear fusion and moon mission together. So thank you, Makbul, again. I think we'll stop. And thank you to the audience for joining. We hope to come back to you many times and bring these interesting discussions. Thanks again. Thank you.
Thank you. Thank you. Thank you.